In this episode, we are turning to one of the most important web application weaknesses for new security students to understand because it shows how a site can become dangerous not only to itself, but to the people who trust it. Cross-site scripting, XSS, is a vulnerability that allows malicious code, usually in the form of browser-executed script, to run inside another user's browsing session as if it came from the trusted site they intended to visit. That matters because modern users place enormous trust in the applications they log into every day, and their browsers extend that trust in ways that can be abused when a page handles untrusted content poorly. A beginner can think of XSS as the site accidentally handing an attacker a microphone inside the user's browser and then letting that attacker speak in the site's voice. Once that picture becomes clear, the rest of the topic starts to make sense, because the real danger is not just that code runs, but that it runs in a place where the browser already believes it is interacting with a trusted application. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A helpful place to begin is with the name itself, because the phrase can sound odd when you first hear it. The scripting part is fairly direct, since the weakness involves attacker-supplied code being interpreted as active content rather than treated as ordinary text. The cross-site part confuses many beginners because it does not always mean one website is literally jumping over to another website in a simple, visible way. What it really points to is the abuse of trust relationships inside the browser, where content from one place or one user input source ends up executing within the security context of a site the victim trusts. That trusted context is what gives the attack its power, because the browser may allow the running code to interact with the page, the user's session, visible data, or actions the site would normally accept from that user. So the core lesson is that XSS happens when a web application fails to separate untrusted content from active executable content, and the browser ends up treating attacker input like part of the application itself. At a high level, XSS works because web applications often take input from users, store it, transform it, and display it back somewhere else. Search terms may appear in result pages, profile information may appear on account pages, messages may appear in a support portal, comments may appear beneath articles, and dashboard values may be inserted into page content dynamically as the application loads. If that untrusted content is placed back into the page without being handled safely, the browser may interpret it as instructions rather than as plain data. That is the central failure. The application is supposed to tell the browser what is real page logic and what is merely user-supplied content. But when it blurs that line, the browser does what it was built to do and executes what it thinks is legitimate page behavior. The user then experiences the result inside a trusted session, which makes the attack especially dangerous because it can look like the site itself is causing the action rather than an outsider. One common form of XSS is the kind that appears in a request and comes back immediately in the response, often through a search page, an error display, or some other place where user input is echoed back quickly. In that situation, the attacker usually creates a specially crafted request and then gets a victim to load it, perhaps through a link, a message, or a page that causes the request indirectly. The vulnerable application takes that input and places it into the page response without handling it safely, and the victim's browser executes the harmful content when the page loads. This matters because the application itself becomes the delivery vehicle, even though the attacker supplied the dangerous input. The site appears trustworthy to the victim. The browser sees the code as coming from the site's response, and the malicious logic runs under that trusted relationship. For beginners, this is a good example of why web security is so much about trust boundaries, because the site is not attacked only by force. It is manipulated into delivering harmful content on the attacker's behalf. Another form is stored XSS, and this one often feels more serious because the attacker's content is saved somewhere in the application rather than delivered only through a one-time crafted request. If a comment field, profile box, shared document area, support ticket, or message board accepts malicious content and stores it, Every later user who loads that content may trigger the attack. That can turn one unsafe input point into a repeated attack surface affecting many people over time. The danger grows quickly when the affected viewers include administrators, moderators, finance staff, or other highly privileged users, because the running code can act inside their trusted sessions just as easily as it would inside an ordinary user session. A weakness like this is powerful not only because it persists, but because the attacker no longer needs to convince each victim individually with a special request every time. The application itself keeps serving the harmful content from storage, which makes the vulnerability feel less like a single trick and more like a hidden trap inside normal site usage. Modern web applications also create a variation where the dangerous behavior happens largely in the browser after the page loads rather than through clearly stored server-side content. Many applications assemble page content dynamically using values from the address bar, page fragments, background responses, or other browser-accessible data sources. If the application's own client-side logic takes that data and places it into the page unsafely, malicious content can execute even when the server did not explicitly store the attack in a database or reflect it in a traditional response. This is important because beginners often imagine web attacks as something the server alone causes, but modern applications distribute logic across the browser and the server in ways that create new trust problems. The key lesson stays the same, though. Untrusted input is being treated like active page behavior instead of being constrained as harmless data. When that happens on the client side, the attack may be harder to notice because the dangerous transformation occurs inside the browser's own handling of the page. The real impact of XSS becomes easier to understand when you think about what code running inside a user's trusted session can actually do. It may read visible data from the page, manipulate forms, initiate actions the user did not intend, capture content the user enters, or send stolen information somewhere else under the attacker's control. In some situations, it can interfere with account settings, trigger administrative actions, alter transactions, or mislead the user by changing what the page displays. Even when it does not fully take over an account, it can still create serious harm by abusing the trust the browser gives to content associated with the site. That is why XSS is not just a nuisance or a cosmetic issue. It can become a path to fraud, data theft, session abuse, reputational damage, and deeper compromise depending on what the affected application allows authenticated users to do. The browser is doing exactly what it normally does for trusted applications, and that is what makes the vulnerability so dangerous when the trust has been manipulated. One of the biggest beginner mistakes is assuming that XSS is mainly about silly browser pop-ups or obvious visual pranks. Those examples have become famous because they are easy to demonstrate, but they can create the false impression that XSS is more annoying than serious. In reality, a harmless-looking proof that code executed is only a demonstration that the trust boundary has already failed. Once that failure exists, the attacker may be able to do far more meaningful things than show a message on the screen. They may abuse the victim's authenticated state, rewrite visible page content to trick the user, collect data the page reveals, or interact with functions the victim is allowed to access. In other words, the harmless demonstration is important only because it proves the door is open. The actual danger depends on what sits behind that door in the specific application, which is why mature analysts do not judge XSS by how dramatic the visible effect looks during a quick demonstration. Another misconception is that XSS only matters on public social platforms or comment-heavy websites where strangers post lots of visible content. Those environments certainly create classic opportunities, but the weakness is just as relevant in business applications, internal portals, help desk systems, administrative dashboards, analytics pages, and line-of-business platforms that reflect or store user-controlled data. In fact, internal applications can be especially dangerous because people sometimes assume that internal users are more trustworthy and therefore do less defensive handling of displayed content. That relaxed attitude can create openings where a single compromised user account or a malicious insider plants content that later affects administrators or other high-value users. XSS is therefore not a public internet curiosity. It is a broader application design problem that can appear anywhere untrusted content is mixed into active page behavior without sufficient care. The lesson for new learners is to stop associating the weakness only with informal websites and start recognizing it as a general failure to separate data from executable content in web-based systems. Defending against XSS starts with a simple but powerful principle. Untrusted input must be treated as data, not as instructions. That sounds obvious, but many application failures happen because developers and designers lose track of where content came from and how the browser will interpret it when it is placed into a page. Good defensive design requires careful handling whenever user-controlled data is shown back to users, inserted into page structure, or mixed into application behavior. Safe handling is not only about blocking obviously suspicious input, because attackers can often find creative ways around simple pattern checks. The deeper goal is to ensure that content originating from users or other untrusted sources is rendered in a way that keeps it from becoming active browser logic. This is why experienced defenders talk so much about output handling, rendering context, and trust boundaries. The vulnerability usually appears not because the application received input, but because it later reused that input in a dangerous way inside the page. This is also why defense cannot rely only on filtering for a few bad patterns at the front door. A beginner might imagine the solution is simply to search input for dangerous-looking code and reject it, but real applications handle content in many different places and many different formats, and attackers are often creative in how they represent payloads. More importantly, a value that is safe in one part of an application may be dangerous in another depending on where it is placed and how the browser interprets that position. Content displayed as plain text is not the same as content inserted into an active page structure, a script block, an event-driven element, or a browser-handled attribute. That means the application must understand context, not just content. Strong defenses are built around the principle that the same user data may need different handling depending on where it is being rendered. For students, this is a crucial insight because it shows why XSS is often a design and output problem as much as an input problem. Detection and analysis of XSS also require careful thinking because automated tools can help but do not always see the full picture. A scanner may notice that user input appears in page responses or that a certain pattern seems unsafe, but the analyst still needs to determine whether the browser would actually execute the content, under what conditions, and with what real consequence. Some instances are easy to confirm, while others depend on certain workflows, authenticated roles, or client-side page behavior that automation may only partially understand. That is why validation matters so much. The security team needs to know whether the issue is reflected immediately, stored for later viewers, or triggered through browser-side logic after the page is loaded, because each of those patterns affects both risk and remediation. Good analysts therefore approach XSS findings with curiosity and discipline. They want to understand not just whether code can run, but where the unsafe trust boundary is, who can reach it, and which users would be harmed if the weakness were abused. Business impact can vary widely, and that is why context-aware analysis matters so much for XSS. A small reflected issue on a low-value internal page may deserve attention, but a stored issue on an administrative review console may demand immediate action because it could let an attacker operate through the browser session of a privileged employee. A weakness on a public customer portal may expose brand trust in customer accounts, while a similar issue on an internal finance tool could affect approvals, records, or sensitive operational decisions. The technical category is the same, but the real-world urgency changes based on who uses the application, what privileges those users hold, what data is visible in the affected pages, and how much the site is trusted by those users. This is one reason XSS remains so important in modern security. It is not only a browser quirk or a coding mistake. It is a failure that can place attacker-controlled behavior directly inside business-critical user workflows, and that can create consequences far beyond a single-page render. The reason this topic deserves such attention in a beginner course is that XSS teaches several foundational security lessons at once. It teaches that trust can be abused without breaking through a system in the dramatic way people often imagine. It teaches that user input is dangerous not simply because people type into forms, but because applications often reuse that content in places where the browser grants it meaning and power. It teaches that the browser is part of the attack surface, not just a passive viewing tool. It also teaches that business risk depends on context, because the same technical flaw can have very different consequences depending on who encounters it and what the application allows them to do. Once learners understand XSS well, they often start seeing web security more clearly overall, because the weakness exposes how fragile the line can be between trusted application behavior and attacker-influenced content when that line is not enforced carefully. The big takeaway is that cross-site scripting, XSS, is a vulnerability in which untrusted content is allowed to become active browser-executed behavior inside the trusted context of a web application. That trusted context is what gives the weakness its real power, because the code may run with access to the page, the user's session, visible data, and actions the application would normally allow from that user. Whether the issue appears through immediate reflection, stored content, or browser-side page logic, the central failure is the same. The application does not keep untrusted data separate from executable content strongly enough. For defenders, that means the job is not merely to spot flashy demonstrations, but to understand where those trust boundaries break, which users are exposed, and what the resulting code could do inside the affected workflow. Once you understand that clearly, XSS stops being a strange-sounding web term and becomes what it really is, a powerful example of how small handling mistakes in trusted applications can turn the browser itself into a tool for the attacker.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.